So what we're going to do today is to continue our discussion of portfolio theory. And just as a review, remember that we're going to use statistical measures as the foundation of our framework. So we're going to have the mean EX, the variance X, which is the squared deviations from the mean weighted by their probabilities and sum. In other words, we're taking the expectation of X minus EX squared. Now remember, we're thinking about things in terms of stock returns. So our random variables here are stock returns. We often want to have measures of how spread out things are, which have the same units as mean, and that's what standard deviation is. We're going to be talking about portfolios of stocks, so we're going to need to know what the covariances are. And remember, the covariance of two stocks, X and Y, is the deviation of X from its mean times the deviation of Y from its mean in a particular state, and then we weight by probabilities and sum across states. In other words, we take expectations. If two things have negative covariance, what does that mean? They move in opposite directions, yeah. So negative covariance means they move in opposite directions. Positive means they tend to move together, so they're both above the mean and below the mean together. The units for covariances, again, are percent squared if we're talking about stock returns. It's also useful to have a unit-free measure, and that measure is correlation. And that's the covariance of X and Y divided by the standard deviation of X and the standard deviation of Y. The lowest correlation you can have is what? -1. The highest is +1. If two things are independent, the correlation is 0. So those are our basic measures that we're going to be using. Now, the key ideas that we're trying to develop for this part of the course, first of all, we've got to start thinking in terms of portfolios of stocks. Don't think in terms of investing stock by stock anymore. Think about creating portfolios. What matters to people is the portfolio risk. And what we'll see is that what's key is, for individual stocks, how do they contribute to the risk of the portfolio? So if you add a stock into a portfolio, what happens to the portfolio risk? As we've seen, there are two kinds of risk. Risks that you can diversify away by holding a portfolio of stocks. Those essentially are the independent part of the risks. And you can get rid of that for free. That's what diversification does. What you're left with is the non-diversifiable risk. That's the risk that's driven by the underlying economy, by the business cycle, and that you can't diversify away. So that's the risk that matters. We talked a little bit last time about diversification. As I mentioned, that's the risk that can be diversified away, the independent risk. That's when you have zero correlation or zero covariance. We looked at a very simple example last time with two-point distribution, so we can think of the stocks as being like coin tosses. If we have a tail, we get a 0 payoff. If we get a head, we get a payoff of 2. It's a 50-50 probability. If we just invest in one stock like that, the mean is 1. That's 0.5 times 0 plus 0.5 times 2, which is 1. And then the variance is 1. The way we get that, we look at the deviation from the mean here, which is minus 1. We square it, which gives us 1. We multiply by the probability and give us half. We do the same for the next state. That's 2 minus 1, which is 1. For the deviation, we square it. We get 1. We multiply by the probability. We get a half. Half plus a half is 1. So that's what happens if we've got one stock. What we looked at next was if you diversified. So now if we invest in two stocks, X1 and X2, we put half our money in X1 and half our money in X2. Since there are two stocks, 2 coins, we can get 4 possible outcomes. We have 2 tails, tail, head, head, tail, and 2 heads. If we get 2 tails, the portfolio payoff is 0. Tail, head, we get a half times 0 plus a half times 2, which is 1. Head, tail, the other way around, but we still get 1. 2 heads, we get 2. If we've got independent stocks or independent coin tosses, they're equally likely, those 4 states. The mean stays at 1 if you work it out. But the key point is that the variance drops. And the reason that the variance drops is that in the tail head and the head tail states, we get one stock giving us 0 and the other stock giving us 2. So we end up with the 1 altogether. So in these states, the tail head and the head tail, you're at the mean. So what's the contribution to the variance? 0. There's no deviation from the mean, and so no contribution to the variance. So all you're left with is these 2 states, which have a deviation of 1 and minus 1 from the mean. So they give you a variance of a half, but you've got rid of half the variance. So by diversifying, even with independent stocks, you get them cancelling out by chance half the time. Does everybody see that? That's the basic idea of diversification. Now, if we have a -1 correlation, that means when one's a tail, what's the other? Head, and vice versa. So now, all the probability weight is on the 2 ones where the 2 states where they cancel out. So now what's the variance? If you're always at the mean, then the variance is 0. And that's what's happening here. If we go to the other extreme of +1, then we're back to having one stock, essentially. You get one tail, you're going to get another tail. If you get one head, you're going to get another head. But you never get any cancelling out because the 2 outcomes are the same. If you had a correlation of +0.3, what would that mean? How much cancelling out would you get? Well, you get some, because even though it's +0.3, there's still some jumping around in opposite directions. That lowers your variance. So we've got the whole spectrum as we go from +1 to -1 with the variance reducing. Any questions about the 2 stock case? Okay, so that's the simplest idea. Now if we add more stocks in, which are just like this 2 stocks, and they're independent, then the probability of getting the extreme outcomes becomes much smaller because, for example, if you've got 4 stocks or 4 coins, what's the probability you get 4 tails? It's going to be a half times a half times a half times a half, which is a 16th. That's quite small. Similarly, 4 heads is a 16th. What you're putting the probability weights on are cases where you've got cancelling out. So some heads, some tails, they're cancelling out. You're getting closer to the mean. If you're closer to the mean, what's happening to the variance? It's going down. As you add more and more stocks or more coins, you get closer and closer to the mean because you're getting lots and lots of cancelling out. The extremes become very unlikely. And that's this case of multiple independent stocks and the variance going to 0.